Alright, Mary needs to clean the windows on the second floor of her house. The ladder is placed 4 feet from the house. The windows are 15 feet up. How long does the ladder need to be to reach the window? Round your answer to the nearest tenth if necessary. So she's got this ladder, she's leaning up against her house. That's 4 feet from the house. Windows are 15 feet up. We need to figure out how long this is. We don't have to use all that stuff, all the trick stuff. All we gotta do here, if you know two sides of a triangle, is use Pythagorean theorem. A squared plus b squared equals c squared. Notice that the ladder, what we're looking for, we'll call that x, is across from the right angle, so that's the hypotenuse, so that's going to go in the c squared. The a and the b are 4 and 15, so 4 squared plus 15 squared. 4 squared is 16, 15 squared is 225, 16 plus 225 is 241. 241 is not a perfect square number, so that when we take the square root, it's not going to come out even. Take your calculator, hit second, square root, 241, enter. That gives you about 15.5, so we'll say that the ladder needs to be about 15.5 feet long. Well, you go somewhere, they're not going to say a 15-foot ladder, so the ladder would have to be probably 16 foot, 18 foot, or 20 foot, something like that. All right, angle of elevation, angle of depression. Angle of elevation is just this. If I'm standing down here, looking straight out, and then all of a sudden, some reason I need to look up. That angle is called an angle of elevation. Notice if I come out here and do this, it forms a right triangle, and we're going to use that a lot with our trig ratios. Angle of depression. Maybe I'm standing on top of a building. I'm looking out, and for some reason I look down. That angle is called the angle of depression. Again, if you look at it, form a right triangle there. Just be careful with these, because a lot of times they'll complete them like that. You got to know that this angle of elevation right here, if we look at this, when we were talking about parallel lines, if this top line and this bottom line are parallel, then these two angles are alternate interior angles, and they have to be the same. So if they told you this angle was 52 degrees, you might have to know that that angle up there is also 52 degrees. All right, reviewing some of the stuff that we went over. If you have the worksheet or the packet, some of you may have, you may not have. I'll try to draw the pictures up here so that as we go over it, it'll make sense even if you don't have the packet. Number 1 on the first page, reviewing some things that we covered before this section. Got a right triangle, that angle's 60 degrees. This side's 24. They don't tell us this angle, but if we have this angle's 90, that angle's 60, then this has to be 30 degrees. And therefore we have a 30, 60, 90 triangle. And every 30, 60, 90 triangle, you should know how to label your sides. The side across from the 30-degree angle, we always label L. Side across from the 60-degree angle, L times the square root of 3. Please make sure you don't mix that up. It's always square root of 3. And the side across from the right angle is always 2L. The only one that they told us anything about was this one. So that's where I get my equation from. My equation is what I labeled it and what they told us. So 2L equals 24. Divide by 2. L equals 12. Well, that means wherever I see L, I stick 12 in. So I come over here to this side. That means this side has to be 12. If I come here, I put 12 in place of L right there. That means this side is 12 times the square root of 3. So again, with 30, 60, 90, most important thing, labeling your sides. Side across from 30 is L, side across from the 60, L radical 3, side across from the right angle, 2L. Number 4 on the front page of the worksheet, or of the packet, gives us this triangle. This angle they tell us is 45 degrees. This is 8. Well, if this angle is 45, this angle is 90. This other angle has to be 45. This is a 45, 45, 90 triangle. And again, all the stuff that we learned about sine, cosine, and tangent would work for these, but it's easier if you remember the patterns for the 30, 60, 90, and the 45, 45, 90. Two sides across from the 45 degree angle should be labeled L. Side across from the right angle should be L times the square root of 2. Well, the equation we're going to set up this time, all we got to do is set up L equal to 8, nothing to solve there. So we know anywhere we see L, we stick in 8. That means this side over here is 8. This side over here, if we put 8 in that place, is 8 times the square root of 2. A couple other things to remember with the 30, 60, 90, and the 45, 45, 90 triangles. If they tell you something's a square, you know that you have all right angles. And you know that if you draw in a diagonal, the two triangles that are formed are both 45, 45, 90 triangles. So when you have a square and you draw in a diagonal, you have two 45, 45, 90 triangles. Another thing, if you have this triangle, that tells us that it's equilateral. So that means all the angles are 60 degrees. And if we draw an altitude, which comes down and forms a right angle in that triangle, then we have a 60 degree angle here, a 90 degree angle here. Well, that tells us this angle has to be 30. So these two triangles, when you have an equilateral triangle and you draw in an altitude, each one of them is a 30, 60, 90 triangle. And you can use all those rules. All right, on these next parts, we're going to deal with sine, cosine, tangent. You probably need your calculator. So make sure you have it ready, either a calculator like this, or if you have the bigger calculator, the TI-83 or 84, what we're going to be using on them, sine, cosine, and tangent buttons. So make sure you can find those on there. On the second page of the packet, if you have it. If you don't, again, it's not a big deal. Number 1, they give us a triangle, looks like this. Tells us this is T, this is R, this is S. Remember, anytime they give you those letters in this book, the side across from the big R, so this side over here, they're going to label little r. Side across from the big S, they're going to label little s. Side across from the T, they're going to label little t. They just use the lowercase letters for the sides and the uppercase letters for the angles. And this time they tell us that little r is 16, little s is 30, and little t is 34. They want us to find the sine of angle r, cosine of angle r, and the tangent of angle r. They also want us to find the sine of angle s, cosine of angle s, and the tangent of angle s. I'm just going to find the fraction part of it and reduce it for you, and then you can change it to a decimal. If we're dealing with angle R first, that's this angle, so we got to label our triangle. That's the opposite leg. Across from the right angle is the hypotenuse. And then the other side's called the adjacent leg because it's hooked to the angle that we're dealing with. Remember SOHCAHTOA again. Sine deals with opposite and hypotenuse. So 16 over 34, reduce that down, and it comes out to be 8 over 17. You can change that to a decimal by dividing it. Cosine deals with adjacent over hypotenuse, so 30 over 34. Reduce that down, it reduces to 15 over 17. You can change it to a decimal. And then tangent deals with opposite and adjacent. So that is 16 over 30. Reduce that down, comes out to 8 over 15. Change that to a decimal yourself. So that's all in for angle R. Angle S, if you remember, if we're dealing with the same triangle and it's just a different angle, it switches. This becomes the opposite leg, and this one becomes the adjacent leg. But if you've already found all these up here for angle R, then when we do angle S, if you remember, the sine and the cosine are just going to switch places from angle R to angle S. So the sine of angle S would be the cosine of angle R, which was 15 over 17. The cosine of angle S would be the sine of angle R, which was 8 over 17. And then the tangent is just the reciprocal of this one. So you just take the 8 over 15 up here and flip it over. That's 15 over 8. And again, you could change all those into decimal forms by using your calculator. And number 3 on that same page, all you're going to do is grab your calculator. And on your calculator, you're going to hit for number 3. Instead of hitting second like we were doing, now you actually know the angle, so you're just going to hit the sine button, then hit 5. Then again, you can close the parenthesis if you want. Then you're going to hit enter or equals, whichever your calculator says. So you just hit sine 5, hit enter, and it tells you that the sine of a 5-degree angle is 0.0871 or 72. We round it up. So that's all you're going to do. Number 4, they say the tangent of 23. So you're just going to, on your calculator, you're going to hit tangent 23. This time we know the angle, so we're just looking for the tangent. The other problems we were doing, we knew what the tangent was and we were trying to find the angle. And we'll do some more of them here in a minute. Hit enter. You get 0.4245. And on the packet, 3 through 8 there on that second page, all basically the same thing, just using your calculator. 9, 10, and 11, you do the same thing that we did on number 1. Just find it, but you're only finding part of it. You only have to find like the tangent or the sine. You don't have to find all 3 parts. Number 12. They tell us this time. Sine of angle B equals 0.2985. This time we're actually looking for the angle, and we know the sine. So the buttons you're going to hit on your calculator, hit second. Then you hit the sine button, and again on your calculator it's going to pull up something that looks like this, tells you doing the reverse of the sine, or the inverse of the sine. And then you punch in your number, which is 0.2985, and then hit enter, or equals. So second sine 0.2985, close the parenthesis if you want, hit enter, and it tells you the sine. So the measure of angle B, and we're going to round ours off to the nearest degree, So we'll say measure of angle B is about 17 degrees. Number 13, they say tangent of angle A equals 0.4168. We're going to do the same thing, except this time you hit tangent, you hit second, tangent, put in your number, 0.4168, hit enter. That tells you the measure of angle A. We're going to round it off to about 23 degrees. All right, on number 18, we're looking for an angle. So you're going to do basically the same thing every time you're looking for an angle. Then we'll do some where you're looking for sides, and you do the same thing on those. It'll be the same routine over and over again. Got to label your triangle first. Since we're looking for this angle, that's probably the one that we want to deal with. So this is the opposite leg. This is the hypotenuse. This is the adjacent leg. Again, usually there's going to be one part that you really don't care about. This time we really don't care about the adjacent leg. And all you're going to do every single time is set up an equation. You got to figure out from your SOHCAHTOA which trig ratio you're using. Well, this time we care about the hypotenuse and the opposite leg. Well, that's the sine. So when we set up our equation, we write sine, and it's always the angle next. Well, the angle this time is just x equals our ratio. Opposite over hypotenuse, so 13 over 27. Then when you're looking for an angle, all you got to do is take your calculator and you hit second. So on this one, we're going to hit second, sine, and then we're going to punch in our 13 divided by 27. So I hit second, sine, 13 divided by 27, and I like to close my parentheses just to be sure. And I end up with 28.7822 something. Well, we're going to round it off, and we're going to say that x equals, since it's an angle, we're going to round it off to nearest degree. X equals about 29 degrees. Number 19, sort of the same setup. We're looking for an angle. So I'm going to label my triangle. That's the opposite. That's the hypotenuse. This is the adjacent. We really don't care about the hypotenuse this time. Opposite and adjacent, we look up here. The tangent is the one that deals with opposite and adjacent, so we write tangent. Then our angle, which is x this time, equals opposite over adjacent, so 27 over 8. And we're going to do the same thing we did on the last one. We're going to hit second, tangent, punch in our 27 over 8, then hit enter, and it's going to tell us what our angle is. So we're going to know that x equals however many degrees, and again we'll round it off to the nearest degree. So second, tangent, 27 divided by 8, and I ended up with 73.5, so we'll say about 74 degrees. All right, 20 is a little different because this time you're looking for a side. You still go through. We know we have the 33-degree angle there. That's the angle we want to deal with since they gave it to us. So we label the triangle according to that angle. That's the opposite leg. That's the hypotenuse. This is the adjacent leg. We really don't care about the opposite leg this time. We care about the hypotenuse and the adjacent. Well, hypotenuse and adjacent, that's cosine this time, so we set up our equation, our trig ratio, then our angle, which before had been x, but now we know the angle, so it's 33, what we put in there, equals, then our fraction. Cosine is adjacent over hypotenuse, so x over hypotenuse, which is 19. What I always do when I'm looking for a side, I put a 1 underneath that, and that makes that a proportion. We talked about this. That makes that a proportion. When you go to solve that proportion, you solve it just like every other one. But the first thing we gotta do is get rid of this word up here. And the way you're gonna get rid of that is by taking your calculator, and you don't hit second this time, you just hit cosine 33 degrees, or cosine 33, hit enter, and it tells you, and you could also use the chart for this, that the cosine is 0.8387 over 1 equals x over 19. Now we solve it just like a proportion. Cross multiply, 1 times x is just x. And then take your calculator, 19 times 0.8387, and we get 15.9353, so we'll say, since it's a side this time, we'll say it's about 15.9. We didn't have any units, so whatever the units were. So that side right there is about 15.9. All right, on the word problems, on the 3rd page of the packet, if you have the packet, otherwise I'll read the problem to you. It says the angle of elevation from point A to the top of some hill, so this angle right here, they're telling us is 49 degrees. That's the angle of elevation. So you're standing down here looking up at the top of some hill over here. If you are 400 feet from the base of the hill, so you're 400 feet away from the hill, how tall is the hill? So this is going to be our variable, x right there. And all we're going to do again, we want to deal with this angle because that's the one they tell us. We're going to label the sides according to that angle. Opposite leg, that's the hypotenuse. This is the adjacent leg. And then SOHCAHTOA. So SOHCAHTOA, we don't really care about the hypotenuse this time. We're dealing with the opposite and the adjacent. Opposite and adjacent tells us we're using the tangent. So we do the tangent of our angle that we have, which is 49 degrees, equals something over something. Well, tangent is opposite over adjacent, so that'd be x over 400. Put a 1 underneath this. Take your calculator and you figure out what the tangent of 49 degrees is. Everything else stays the same for now. So you just hit tangent 49 on your calculator, hit enter, and it tells us it's 1.1504. We cross multiply, and we end up with x. 1 times x is just x. 400 times 1.1504 ends up being 460.12 or so feet. That's how tall the hill is, about 460 feet. Main thing here is to label your sides and then figure out which of the 3 trig ratios you're using. Okay, number 4 on the same page on the packet, on the 3rd page of the packet, and I'm going to draw the picture up here in case you don't have the packet. They give us some tower standing here, and apparently there's some person standing down here on the ground. That person's looking over here, and they're looking up here, and they tell us that this is 5 feet. The person apparently is about 5 feet tall. The tower, the whole thing, is 132 feet. And this is from, the person is about 100 feet from the tower. And we're looking for this angle right here. So the angle of elevation that the person's looking up at the top of the tower. And what I'm gonna do is I'm gonna redraw, we have this little rectangle shape down here, we really don't want it in our problem, we want just the triangle. So I'm gonna redraw the triangle over here. We're looking for X, we know this is 100. Now the problem is this side over here is a little different because it's not this whole 132, because we gotta get rid of this 5 foot down here. Well, all we do is take 132, subtract off 5, and you get 127 for this side. Now it's going to tell us, if we solve this, it's going to tell us the angle of elevation. We set up, or we label our sides, we're dealing with this angle. So that's the opposite leg, that's the hypotenuse. This is the adjacent. Again, every single time you gotta label your sides so you know which ones you're dealing with. We don't care about the hypotenuse, we care about the opposite and adjacent. SOHCAHTOA, use that again. Remember SOHCAHTOA, if we're dealing with the opposite and adjacent, that's the tangent. So we do the tangent of our angle, which is X, equals opposite, 127, over adjacent, which is 100. Well, this time we're looking for the angle, so we're just going to completely use our calculator, and this time you're going to hit second, tangent, and then you put in 127 divided by 100, hit enter, and that tells you that X equals about, it says 51.78 something something. So about 52 degrees is the angle of elevation. All right, on this problem, guy wire is attached 100 feet to a 100-foot tower that is perpendicular to the ground. The wire makes an angle 55 degrees with the ground. What's the length of the wire? Well, we're dealing with this angle, so we're going to label this, that's the opposite. It's our right angle, that's the hypotenuse. This is the adjacent. We really don't care about the adjacent this time, so we're using hypotenuse and opposite, which is the sine. So we do the sine of our angle, which is 55, equals opposite over hypotenuse, so 100 over X. Again, put a 1 underneath this. Use your calculator to figure out what the sine of 55 is. Just hit sine 55, and it tells you that it's 0.8, that's a decimal, 0.8192 over 1 equals 100 over X. We cross multiply. You get 0.8192x equals 1 times 100 is just 100. Divide both sides by 0.8192 to get x by itself. So 100 divided by 0.8192, and I end up with about 122.1. And our units were feet. So the wire is about 122 feet long. Jet airplane begins a steady climb at 15 degrees and flies for 2 miles. What is this change in altitude? So we got this airplane starting here, it's going this way, that flies for 2 miles. Now first it was steady climb of 15 degrees, so it's going up 15 degrees, that's its angle of elevation. And we're trying to find its altitude, so that's going to be right here. It's right angle. And this isn't really a great problem because we're not sure if they're talking about 2 miles as far as the earth goes, which would be down here, or 2 miles as far as the airplane goes. I'm going to put it up here, 2 miles. that it actually flew 2 miles through the air. So we're dealing with this angle, that's the opposite leg. This is the hypotenuse. We really don't care about the adjacent this time. So we're using hypotenuse and opposite, which is sine. So you do the sine of your angle, which is 15 degrees, equals x over 2. Put a 1 underneath that, figure out what the sine is by using your calculator. Sine 15 equals 0.2588 over 1, x over 2, cross multiply, end up with x equals about 0.5176, and this is actual in miles, so the altitude is about 0.51 miles. If you wanted to change that to feet so it made more sense, remember that there's 5,280 feet in a mile. So you just take that 0.51 times 5,280. And it's saying that they're about 2,693 feet off the ground. This is a problem that I think I got off of one of the old OGT tests or something. Remember, if you have a right triangle, if this is 30, this angle right here has to be 60, so this is a 30, 60, 90 triangle. And 30, 60, 90, this side's labeled L, this side L radical 3, and this side over here is 2L. Well, we know this one, so 2L has to equal 8. Divide by 2, L equals 4. So that means this side down here is 4, and this side is 4 times the square root of 3. It says, what is the approximate area of the triangle? Well, what you do to find the approximate area is 1/2 times base times height. This is your base, this is your height. And you can change that 4 radical 3 into a decimal just by taking the square root of 3, then timesing that by 4. And you get about 6.9. So you're just going to have 1/2 or 0.5 times 4 times 6.9. Let's get rid of that. 0.5 times 4 times 6.9. Use your calculator for that. So 0.5 times 4 times 6.9. And I come up with about 13.8. The closest one that they have is 13.9. Find all missing parts in a right triangle. The two legs are 7, 24, and 25. So we draw a right triangle. This is 7, this is 24. Oops, sorry, I said the answer. Well, this fits into that family, so you could use Pythagorean's theorem to find this side. But we know it's 25 because it fits into that 7, 24, 25 family. So that's one of the parts. Now we still got to find the two angles. So let's say we find this angle first. Well, this is the opposite leg. This is the hypotenuse. This is the adjacent leg. And you pick whichever one you want. It doesn't matter which trig ratio you use as long as you match up the sides right. I'm going to use sine just because that's the first one. So we do the sine of our angle x equals, sine is opposite over hypotenuse. So 7 over 25. Take your calculator and hit second, sine 7 divided by 25. And it tells us that x is about 16 degrees. Well, that means this angle right here is 16 degrees. To find the other angle, we could do the same thing, but an easier way is if we know one angle is 90, one angle is 16, we add those two together and get 106, then just subtract that from 180, because 3 angles of a triangle got to add up to 180, and we come up with that angle right there is 74 degrees, and we found all 3 missing parts of the right triangle. Alright, your assignment is either, it could be this page, depending on what we do this year. So it could have been this page, or it could have been a worksheet. Sometimes I switch them up